Hello, Mary Bacho. Hello, my kids. Hello, my dear warriors. Hello, my dear Enlites. Welcome aboard to the amazing Tattva problem solving session with me, Shreyas, your physics master teacher. And today we are going to solve some amazing problems from the chapter of center of mass collisions from this Tattva booklet. Now, this is how a Tattva booklet looks like. It's a Vedantu material, Vedantu coaching material. All the students who are in Vedantu know this. So there are beautiful theory pointers, summaries, solved examples, important concepts, mistakes that you do, exercise 1, exercise 2, exercise 3, previous year questions, and also the difficulty level increases from small or simple to hard. Not just that, you are seeing that the Tattva booklet has bifurcations based on the subtopic also. So I have picked up some problems which I feel we can solve, which we will enjoy, which we will learn a lot in today's lecture. My name is Shreyas. Those of you do not know me, that's my small introduction slide. You can go through it. By the way, I am teaching for more than like 10 years, and I'm very happy and proud that many of my awesome students have done extremely well in their examinations and now are in the top-notch premier institutes of the country, and some of them are even now outside. So here I am to coach you, to guide you, to mentor you on this channel Enlite. So make sure you have hit the like button and also hit the subscribe button so that you do not miss any of the lectures that are going to come in the days to come for all of you. Welcome. My aim is All India Rank 1. Very good. Hello Nandini, hello Hita, Space Station, Yalini, Joyce Mary. Welcome aboard Vikash and all the other amazing students on the channel. Make sure you are very regular on this channel. There are beautiful playlists also which has all the important concepts, all the important formulas, all the important problem practice from all the chapters, all the grades 11th and 12th. So whether you are 11th, whether you are 12th, whether you are a dropper student, just go to the playlist. You will see all the chapters arranged beautifully for you. So make the best use of this, guys. So let's begin with the class and let's start with the first question. Okay. If you are a Vedantu student, then you can definitely open up Tattva and you can side by side start solving the question. You can also see that it is there. Yes. Very good, Muthu Kumar. You have started doing 0 to hero along with PYQ. That is very good. Hi, Najmuz. Hi, Bhupati. Hello, Anamika. Welcome aboard. Hi, Senthil Kumar. So this is the first question coming up on your screen. Let's try to understand. There is a mass of 100 gram hits a wall and rebounds at the angle as shown. What is the force applied on the mass by the wall? Interesting question. So when the mass collides with the wall, the mass has two kinds of momentum. Like you can see, there is one momentum in the x direction. There is another momentum in the y direction. When it collides and comes back, this is the new x momentum. This is the y direction momentum. Like you can see over here very, very clearly that the y momentum is upwards. Here also it is upwards. The angle is also same. Speed is also same. That means the y momentum did not change at all. This is very important to understand and then solve the problem, that which momentum has actually changed. When it hits, the y momentum here and here did not change. Why? Mass is same, speed is same, angle is same, direction is same. What more you want? So y momentum did not change, but the x momentum has definitely reversed. So x momentum has changed, and wherever the momentum changes, there must be some kind of force. So hence, I will definitely say that the force is actually the force only in the x-axis. The force will only act in the x-axis, and it is because of the change in the momentum in the x direction upon the time taken to change it. Now if you notice, final momentum is here, initial momentum is here. So if I take the final momentum as px, initial momentum will be negative px. Reason for this minus sign, this is exactly opposite of this, and momentum is a vector quantity. So this divided by the time, so this will become plus, so it will become 2 times of px divided by the time. Now the momentum in x direction, think about it carefully, guys. This is your mass into velocity, the momentum. This is 60. Naturally, this is 30 degrees. This is also 30 degrees. So the x momentum will be mv cos 30. mv cos 30. So I should just put over here m times v cos component of that momentum of 30 degrees. That's it. The whole thing divided by the time interval. Now you just substitute everything. 2 into mass. Mass is 100 gram. 100 gram is 0.1 kg. Then into velocity. Velocity is given to be 5 meters per second. Great. Cos 30 is root 3 by 2. The whole thing divided by time. Time interval for the contact is 2 into 10 to the power minus 3 seconds. Now you can clearly see that this 2 into 5 will become 10. This 2 into 5 will become 10. This 10 and 0.1 will become 1. Okay. And 2 into 2 is 4. So it will become just 1 by 4. And this root 3 is on the top. 10 to the power 3 will go on the top. Okay. 10 to the power minus 3 goes on the top. It will become 10 to the power plus 3. 1 by 4 is 0.25. So 0.25 into 10 to the power 3 into root 3. What is 0.25 into 10 to the power 3? It is 250 root 3, and this will be Newton. So that is your force. You can see it is here also, it is here also. But we know that when it hits the wall and comes back, the force on the ball by the wall will be towards the left hand side. By the wall, on the ball. So that force has to be in this direction because it will come back over here. So not towards the right, but it will be towards the left hand side. Very nice. Option C is the correct answer. 250 root 3 Newton towards the left. Very good, Specialize. Welcome A Dimple Classes Talk. Welcome Bacha, all the new students. Surya, why don't you write a comment after the session ends? Maybe I will definitely advise you, and all the students who watch that and see the comment also will be benefited. All right. Good evening, Kushi. Nice to see you. Why would I not write symbol kg while substituting it, sir? It confused. Why you write? Oh, it was just to show you that, this is what I have substituted. There was no need to, put down the units over here. This was just to tell you what and all values I have put down. That's all. Don't get confused. I don't really have to write down the units. Even if I don't write, it is perfectly fine. Okay? So if you are getting confused, no issues, guys. Remove this, remove this, remove this. No problem. It looks simple. Okay? No problem at all, Aditya. Is that okay? Chalo. Let's do the next question coming up on your screen. Tattva problems. There is a bullet which hits a block kept at rest on a smooth surface. It gets embedded in it. Which of the following does not change? Which of the following does not change? Hi, Alvin Bas. So draw the diagram. It makes it look little bit easier. There is this bullet. It is going and hitting it. After it hits this block, you will see both of them will move together. Okay. Which of the following does not change? Linear momentum of the block definitely changes. The momentum of the block has changed. So momentum changes. Kinetic energy of the block, definitely it changes. It was at rest, now it is in motion. Gravitational potential energy of the block, here it was, now it is here. It did not go up, did not go down. So yes, this did not change. Temperature of the block definitely will change because the bullet got embedded in it. So there is some loss of energy, and that loss goes as heat, and because of the heat, the temperature will definitely change. So things which do not change is option C, the gravitational potential energy. Even the temperature changes. Why? Because there is deformation. The bullet gets embedded in it. So there is some kind of energy loss during that collision because it's a perfectly inelastic collision. In a perfectly inelastic collision, there is always maximum energy lost in it. Yep. Yes, Juhi, C is correcto. Moving on to the next question. Okay, this is also a beautiful question. There is a bullet moving with some speed. Again, just like the previous question, it gets embedded into a big block. How much is the loss in the energy? This is what I was telling you. See, here also in this question I told energy is lost as heat. That is why temperature of the block increases. here this is a numerical question on that similar idea. Let's try to solve this. So this is what happens in Tattva. There are some conceptual questions, then there are some situational based questions, some calculative question, so that you develop the concept. Okay, so here is our bullet of mass 50 grams. Okay, it is moving with certain speed. How much speed? 10 meters per second. It hits a block which is at rest. Okay, the block's mass is 950 grams. This is at rest. After the collision, both of them will move together as one single unit. Now this will be 1000 grams moving with a common velocity v. To find the loss in the energy percentage wise, I obviously would need how much energy was there before, how much energy was there afterwards. Only then I can calculate the loss. Now how do you calculate the final energy? For that you need the final speed. Now how do you find the final speed? Think about it using some momentum conservation. Without that you can't find the final speed, and momentum in collisions is always conserved. So let's try to do this. So the initial momentum, mass into velocity, okay, mass into velocity, so that's 10 meters per second. The other block is at rest, so 0 is equal to, the final mass is 1000 grams because 950 plus 50 is 1000 grams into velocity. This will be also in meters per second. Now there is a deliberate reason why I wrote down the units here. I wanted you to see that even if I put the mass in grams and the speed in meters per second, it really does not matter while I conserve the momentum. Because if I put in grams and meters per second, here also I am putting it in grams and meters per second. So the units will cancel on both the sides. So I'll get the answer perfectly well in meters per second. Is that clear? Yep. So Sripati, if you want to get the concept of momentum conservation really well, there is a lecture of mine in the playlist. Watch that. Okay? It's in the nurture playlist for 11th standard. How to conserve momentum, momentum conservation principle. Lots and lots of questions have been discussed. Just watch that. And today also you will learn of quite a few things. This was moving. This was at rest. This is the total mass. This is the velocity. So this is basically conserving momentum. And why is momentum conserved? Because there is no external force. From outside, this system is isolated. So you can see some of the things get cancelled, like this 0 and this 0. All right. So I will be just left with 50 is equal to 100 into V. So therefore V is nothing but half a meter per second. This is the final speed. But that's not all. I need to find many more things. So let's try to find what is the initial energy first. Initial kinetic energy will be half into mass, which is 50 grams, which is 50 into 10 to the power minus 3 kg, into speed. Speed is nothing but 10, so 10 square. So this is going to be 1 0, 2 zeros, 3 zeros, and this is minus 3, so it cancels. So it will just become 5 by 2 joules. So this is the initial kinetic energy. Similarly, I think I can also find the final kinetic energy, which will be half into mass. 1000 grams is 1 kg. Velocity, I just got it as half. So it will be half square. So this will be 1 by 8 joules. That is your final energy. Now the question says, how much energy is lost? Percentage energy is lost. So the percentage energy which is lost is, first calculate how much is lost upon how much is there initially, and then multiply by 100. So how much energy is lost? This was initial, this was final. So initial was 5 by 2 minus final upon initial, how much was there? 5 by 2. This into 100. This into 100. Many people are saying option A. I don't know. Let's figure this out. So guys, do the math over here. So LCM is 8, of course. So 5 into 4 is 20. So 20 minus 1. The whole thing divided by 5 by 2 into 100. Now 20 minus 1 is 19. So 19 by 8. And this will be 5 by 2. And this is basically your 100. So this 2 goes with 8 4 times. 4 5s are 20. So 20 goes with 100. 5 times. So 19 5s are 95. So this is 95% is the percentage energy lost, which is obviously option number A, like many of you predicted. Very good. So the concept over here was to find the percentage energy lost, we need the final energies. To find the final energies, we need the final velocity. To find the speed, I need momentum conservation. So conserved the momentum, found the speed, found the final energy, found the initial energy. The difference will give me the loss. Initial energy, I put it here so that this is the fraction of the energy lost. If you multiply by 100, this gives me the percentage energy lost. That's all. Hello Munawai, hello Niharika, welcome guys. Is that clear, my dear students? Is this understood? Moving on to the next question coming up on your screen. Okay, predicted. I don't know. Sometimes on YouTube, I feel that many people predict. Okay, somebody saying A, I'll also say A. Somebody saying B, I'll also say B. Hopefully, that is not the case. Many times specialized. I hope you guys are solving it. Okay, so the balls of mass m0. This ball, actually, this should have been blocks, not balls. It's okay. The blocks of mass m0 and m are on a smooth surface. It's not ball. Read it as blocks. Blocks of mass m and m0 are on a smooth surface connected with a string. There is a bullet of mass m0 moving with some speed, collides with the mass m0. Find the speed of m after the collision if coefficient of restitution is given. Beautiful question. Let's try to do this. Hi Shubham Samal, nice to see you back. So I think I will draw the situation before and after. Before is already drawn for me. In that this is already at rest. Even this is at rest. For me, this whole thing is my system. This whole thing is my system. And for this system, I will say that the momentum is conserved. Momentum is conserved. Because this force of collision, this collision is internal. There is nothing which is coming from outside the system. If the string together is my system, the total momentum must be conserved. See if you guys understand it. Great. Now the next part of the problem will be, what will happen afterwards? Well, maybe this mass along with this mass, because they are connected by a string, they both will move together. Let's assume their speed to be v1. This mass over here, maybe it goes left side or right side, I really don't know, but let's just take it as if it's going towards the right side only after the collision. Okay, but with a lesser speed, because after it collides the speed will reduce. So this mass m0 has a new speed v2. This is your m, this is your m0. So this is the final speed of m0 and m together. Both of them are moving together. This is final, this is initial. Okay, the system is still the same. Understand that. Okay, conserve the momentum and also use coefficient of restitution equation. So let's try to do this. First, using coefficient of restitution, which is always how much is the separation upon how much is the approach. How much is the approach? Let's try to find that out. Here, after the collision, the two masses move with v1 speed. The m0 mass moves with v2 speed. The two masses are moving with v1. This point mass m0 is moving with v2. v2 is smaller. v1 is faster. v1, v2. v1, v2. Can you find the relative speed of separation? v1 is fast, v2 is slower. The relative speed will be bigger speed minus smaller speed. So it will be nothing but v1 minus v2. Check this out. v1 minus v2. Everybody with me? I'm so glad. Dharni, you are following it. Yes, my notes are enough, but not just zero to hero. Dharni, please watch the regular nurture and the Pathfinder series to learn even more concepts. Okay, cool. Now, what is the approach velocity? If you notice, this mass is at rest. This mass is approaching with u0 speed or v0 speed. So the approach velocity is just, one is at rest, one is just coming and hitting it. So it is just u0 or whatever, v0. Okay, so this is your E. I think we have to find the speed of the ball of mass m. That means we have to find v1. We have to find v1. So let's just eliminate v2 from here. So for that, what I'm going to do, bring this on the top. So it will become E into V naught or U naught is equal to V1 minus V2. So V2 will be nothing but V1 minus E times of U naught or V naught. Okay, I'll keep this separate. Now let me basically conserve the momentum. This is my second equation. Conserve the momentum of the system. So what is the initial momentum? This is moving, this is at rest. This is moving, so that guy's momentum is m naught, v naught, u naught, whatever you want to say. Other guy is at rest. Finally, these two are moving with common speed v1. So m v1 plus m naught v1, that is one body, together they are moving, plus this mass is moving with v2 speed. So m naught into v2. Now once you write this equation, since I want to find v1, find the speed of the ball of mass m or the block of mass m, so that is v1. So question is demanding us to find v1. So I need to get rid of v2. So like you can see over here, this value of v2 which I found over here, I think I'm just going to substitute it. That's all. Okay, I'm just going to substitute it. Let's see what do I get. Just write it over here. Okay, so I'm going to get over here m naught v naught is equal to, here I have m v1 plus m naught v1 plus m naught v2 is v1 minus this. So v2 is v1. So I'll put v1 over here, and then I'll have minus m naught into this term, which is E times of V naught. Everybody fine till here? Okay, somebody saying answer is B or maybe something else. I don't know. We'll figure it out. Okay, now you have to be very careful while solving this. Identify the identical terms over here. This term is having some things common with this term. This has V1, V1, V1. Interesting. So bring this guy over there. So bring this guy over there and see what happens. Bring this guy over there. M naught and V naught both are common. So M naught and V naught both are common. So 1 plus E will be here. 1 plus E will be there. And here V1 is common. Here V1 is common. And here M is there, M naught is there, M naught is there. Oh, M naught plus M naught is 2M naught. So it will be M plus 2M naught. I had to find V1. So V1 will be this thing, which is m naught, v naught or u naught, 1 plus E, the whole thing divided by this, which is m plus 2 times of m naught. Is such an option there somewhere? I think it is there. Many of you might be correct about it. Yes, option B is righto. Amazing. Till here you solved, and then after that tukka. Okay, so this is what it is. Option B. Yes, Anger Queen. Yes, Joyce Mary. Yes, Munna Bhai. Very good. Yes, awesome. Great. Elimination. Yes, you can use that. Yes, if you want to. But this is the method to solve the question in case you could not eliminate it for some reason. Okay, this is now a direct question. A body of mass m1 collides elastically with another body of mass m2. There is a maximum transfer of energy when one is more, one is less, one is equal, or it doesn't matter whether they are equal or not equal. Yes, Munawai, you had B option. Let me tell you, there is a property which you know about elastic collision. Only when the masses are equal, so this is moving, this is at rest, you will see that after the collision, this mass will come to rest and this mass will start moving with the same velocity. Only for elastic collisions, this is true. So if, for example, one is bigger, one is smaller, okay, and this is moving like this is at rest, then you will see that this mass will still move, maybe with little bit less speed, and this mass will also gain some velocity. So I don't think it has transferred the energy to it completely. Even if this is small and this is big, this is at rest, okay, this is moving like this, you will notice that the smaller mass, maybe it will go like this, and the bigger mass might move with some small velocity. So I don't think it has transferred its energy completely because it still has some of its energy. So that is the problem, guys, because this mass has some of its energy left in either of the cases, either one is more or one is less. So the maximum energy is not transferred. Here, maximum amount of energy gets transferred, So that is this one, because I have been asked to do so. Yes, I'm solving the Tattva questions. Yes, I'm solving the Tattva questions, which is our booklet. So this is how our booklet looks like. Yeah, this is the magnetism module. Similarly, you have the module for all the subjects, all the chapters, 11th, 12th, everyone. Yeah, all the Vedantu students get this. These are just few of them. Each chapter has at least 100 questions. 100 is less, 200, 300 questions of all varieties. At least I'm saying. A small chapter only will have 200 questions. Big chapters have 300, 400 questions. Okay. So moving on to the next one coming up on your screen. Beautiful question. There is a person standing in the middle of the boat. Mass of the boat is 100 kg. Constant speed is the boat's velocity. There is no friction. And now the engine is shut off. Now you have to make sure that the person will move in such a way that the boat comes to rest. The boat should come to rest. So how fast should the person move relative to the boat? Beautiful question. And guys, make sure you're smashing the like button. Yeah, it's very important, or else I will not conduct these kind of sessions. Or the only way I understand what you like or don't like is through your like, not anything else, and your comments. So make sure that you definitely go ahead, and if you want more sessions like this, you go ahead, smash the like button. Shoaib, if you're not done with the chapter, then please don't attend right now. You can watch this session later on, because or else you'll not understand only anything. Joyce Mary, same thing. If you're not read this chapter, my advice is please go through the chapter, watch my lectures. It's there on the playlist, or if you have it in the coaching, wait for it and then watch this class, or else you will just miss a lot of it. You will not understand. Okay. So for solving this, again I will choose my system. And my system is the person plus the boat. The person plus the boat is my system initially. Finally, what happens? Finally, what happens is that boat comes to rest, and this person over here is moving with certain velocity. This is what has to happen afterwards. In fact, this is the trick for solving all the questions on momentum and collisions. Always you will see me 99% of the times drawing the situation before and after. Do not believe me? Check any problem which I have solved before, after. Check any problem that I have solved before, after. All the problems every time before, after. So always draw the situations before and afterwards so that you understand what to do, or else you will mix up and definitely there is a good chance you will do a silly mistake. So please don't do that. Okay, so drawing the situation is very important. Initially, so conserving momentum now. Conserve the momentum. Initially, this mass of the boat is 100, person is 50. So 100 plus 50 together are moving with a velocity of 10. Finally, the boat is at rest. The person of mass 50 is moving with speed v. Great. This is 150 into 10 is equal to 50 into v. This 0 cancels. V is 150 by 5. This is nothing but 30 meters per second is that velocity. So where is that answer? 30 meters per second. Yep, but towards the right, obviously, because I have chosen V towards the right and I got the answer as positive. By chance, I had got the answer as negative. That means whatever I assumed in the diagram is wrong. The exact opposite is correct. So here, luckily for us, velocity came out positive. So this direction has to be the correct direction, which is towards the right side. Okay, everybody with me on this? Gudeti Jayasri, see bacha, let me tell you, those of you are very new to the channel, right? Let me just go down and show this to you. Let me just go down and show this to you. When you are in the playlist, right? So when you are watching the playlist of this channel, just go down and see over here, last minute revision series are there, 0 to hero, formula revision, mock test. Okay, all these are there. 12th standard, that's your second year syllabus is there here. First year syllabus is there here. Nurture physics, this is Pathfinder physics. It's just a name given to the name of the series. So all the chapters are there over here. Okay, bacha, this is what you can do. Okay, clear? Okay. Understood. Let's move on to the next question coming up on your screen. Here it is. There are three rods. There are three rods of the same mass placed in the figure. What will be the coordinate of the center of mass of the system? What will be the coordinate of the center of mass of the system? This is one rod, second rod, third rod. All the masses luckily are same. So this rod's center of mass will be here. This rod will be exactly over here. This rod will also be exactly at the midpoint. Now what are the coordinates? This will be obviously a by 2. This will be also nothing but a by 2, and this will exactly match over here. Isn't that right? So I know the coordinates of all the three masses. What are these masses? These are point particles of the rod. The rod can be assumed here. This rod can be assumed here. This rod also can be assumed here. Is that clear? Okay. Now what you need to do, just use the formula. Let's say x coordinate of the center of mass will be m1 x1, here it is a by 2, plus m2 into x2. The coordinate of the x coordinate will be 0 plus, so this is 0, m3 into x3. x3 is also a by 2, great, upon the total mass. So m plus m plus m. So ma by 2 plus ma by 2 is ma. M plus m plus m is 3m. So this will be a by 3. That's the x coordinate. Obviously, whatever is the x coordinate is also the y coordinate. Symmetry is there. So y coordinate of the center of mass is also going to be a by 3 by symmetry. Hence, the correct answer is a by 3, which is option D. Is that clear? Oh? Is that understood? Oh? Can we move ahead? Okay. Chalo, let's move on to the next question. So concept was symmetry and also identifying that the rod can be assumed like a point particle at these particular distances. Moving on. Beautiful question on your screen. The Telegram PDF will come maybe by tomorrow or maybe by tonight. Okay, just give it some time. Okay, a square plate of side 20 has some uniform thickness and density. A circular part of some diameter is cut out. Find the location of the center of mass of the remaining part. Okay, now whenever you get these kind of questions, what you need to do is that first understand that this is your remaining shape. This is your remaining shape. Out of that, this much part is being removed. So first thing that you need to do is take the identify what is that big shape and what is that cavity which has been taken out. The bigger part is actually this. This is that big solid square. Out of that, one small circle has been taken out. Out of that, one small circle has been taken out. Is that okay? Now, just mark the coordinates, whatever you want to take. Let's say I take this as my y-axis, this as my x-axis. So over here also the same thing will happen. This is x, this is y. Here I think it will be slightly offset over here. I think you'll have to find that distance. What is that y and x? That is not so difficult also, because if you notice carefully, the side of the square is 20 centimeter. So this much distance is 10 centimeter because the side of the square is 20 centimeters. 20 centimeter. The radius of the circle is not given, diameter is given. Diameter is 8 centimeters. Okay, diameter is 8, matlab radius is 4 centimeters. So out of 10, this is 4. How much will this be? Out of 10, that is 4. So think about it. How much will this distance be? This is 10, this is 4. Obviously, this is 6 centimeters. So the center of the circle is at a distance of 6 centimeters. The center of the square is exactly at the origin. This is what I got from pure geometry. Nothing else. Pure geometry, this is what I got. Cool guys, everybody with me on this? Shall I move ahead to the next part? Okay. Now, What I have done is I have identified this is the big object from which this small object has been removed. I identified that the center of the disk is here, the center of mass of the square is over here. The next thing that you need to realize is that this part is this minus this, and this part center of mass formula is given by center of mass of the part over here will be somewhere here, maybe center of mass will be somewhere here because you are taking out some mass from there, will be m1 x1 minus m2 x2 upon m1 minus m2. m1 minus m2. What is m1? m1 is this. What is m2? m2 is this. So m1 x1 minus m2 x2. Now what is m1 m2? What is the value of that? Because I cannot just leave it over here. So that value can be found by simple logic that the mass per any area, unit area is the same. It's a uniform sheet, uniform 2D object. So whatever mass you take per unit area will be the same. So here is what I'm going to do. Sigma, which is nothing but the mass per unit area, will be nothing but the mass of this guy is nothing but m2, area of this guy is nothing but pi into radius is 4, so 4 square. Similarly, for this guy the mass is m1, the area is, well, what's the side length? The side length is 20, right? So m1 by 20 square. This is very crucial step because only through this I get m1 and m2 values. m1 will be sigma into 20 square, which is nothing but 400, and m2 will be, take this guy over here, it will be sigma into pi into 4 square, which is nothing but 16. Now substitute it over here. Value of m1 is 400 sigma into x1, the coordinate is obviously 0, so just put 0, minus m2 is from there 16 pi sigma into coordinate of the second mass, which is nothing but 6 centimeters. The whole thing divided by m1 minus m2, so that is 400 sigma minus 16 pi sigma. You will see that sigma will get cancelled. This is just a 0, so this is also going to be 0. So you will be just left with minus 16 into pi into 6 divided by 400 minus 16 pi. Now just do the math and see what is the value which is going to come out. See, just do the value calculation, and I feel that it is not going to be, obviously it can't be here. Obviously it can't be here. This was like direct elimination. This can't be true at all. Whether it is 0.54 centimeters, no, it is not going to come out 0.54. It is, I think, going to come out some 0.7 or 0.8 centimeters. So it is slightly different from the C value which is given over here. So it is none of the above. So this is not going to be 0.54. This is not going to be minus 0.54. So hence option C is wrong. Hi Praveen. Space station EMSAT syllabus. What do you want me to tell? You want me to tell you what is the syllabus, or you want me to solve problems? I have solved a session of EMSAT on only 11th standard problems. So similarly, if you want me to do for a 12th standard problems, I will do that very soon. Don't worry, bacha. Okay, great. So that is the answer, guys. Moving on to the next question. All right. Two blocks connected by a spring, negligible mass on a surface. Impulse is given to one of the heavier block in the direction of the lighter block. What do you think is the velocity of the center of mass? What do you think is the velocity of the center of mass? Let's draw before and after scenarios. Two blocks connected by a spring of negligible mass placed on the surface. Impulse is given to the heavier block. So let's say this is, this is your 10 kg and this is your 4 kg. Impulse is given to the heavier block with a speed of 14 in the direction of the lighter block. So this is basically 14 meters per second. This Y is going to be at rest because there is a spring over here. So that spring will not compress immediately, it takes some time. Impulse is a sudden force. Impulse is a sudden force. The moment you give the force and you hit the ball with a bat or something, tuck karke, it will get instantaneous velocity. But the spring is not yet going to compress. It's going to absorb the shock a little bit. This mass has hardly moved anything. So that's why that guy is at rest. A lot of people take the velocity of this guy also as 14. That is completely wrong. Now the question is, what is the velocity of the center of mass? The formula is m1 v1 plus m2 v2 upon m1 plus m2. m1 is 10, v1 is 14, m2 into m2 is 4, velocity is 0 upon m1 plus m2. So 10 plus 4. So 10 into 14 is there. This is 0. 10 plus 4 is 14. 14 cancels. It becomes 10 meters per second. 10 meters per second. Yes, that's it. Yeah, the previous question has slightly lengthy calculation. I agree with that. Okay, so straightforward. Concept over here is this impulse. Understand what this impulse means. This impulse will suddenly change the velocity of 10 kg, but the spring absorbs the shock temporarily, and that 4 kg barely it moves. So understand this concept. So that's why this guy is at rest, this guy is 0, and the answer is 10. Next question coming up on your screen, and here it is. Two particles shown in the figure. At time 0, a constant force starts acting 3 kg on the 3 kg mass. Find the center of mass speed at 5 seconds. Beautiful question. Okay. So you will be like, the force is only acting on the 3 kg mass. Correct. Very good. So find the velocity of the center of mass, the particles at t is equal to 5 seconds. Now clearly this mass is not moving. This is going to be always at rest. Why? Because the force is only acting on this guy. So only this guy will move, right? Only this guy will move. So this guy will have some acceleration. How much will be that acceleration? Acceleration is force by mass. Force is 6, mass is 3. So acceleration is 2 meters per second square. Now because of this acceleration, it will get some velocity also. What is that velocity? V is equal to u plus at. U is 0. Acceleration is 2. Time is 5 seconds. So 2 into 5. Correct? Initially, I think none of them were moving. Okay. So this is nothing but 10 meters per second. So this is velocity of the second particle. Velocity of the first particle will always be 0. It doesn't move. So what is the velocity of the center of mass? m1 v1 plus m2 v2 by m1 plus m2. What is m1? m1 is 2. What is v1? 0. What is m2? It is 3. What is v2? That is 10. What is m1 again? 2. What is m2? That is 3. 2 into 0, 0. 3 tens are 30. 2 plus 3 is 5. So this will be 6 meters per second. 6 meters per second. Very good. Option C is correct. Oh, slightly different question. If there was another force on this guy, then you would have found out this guy's acceleration, this guy's velocity in a very similar way. And then again using this formula, you would have got the newer answer. Yes, Juhi. Yes, Krishna. Harsh. Yes, Praveen. Yes, Jai Vignesh. Very good. Oh, is it approximately 0.8? Oh, is it? Yeah, very good. Very good. Yes. So, very good, guys. So that previous question, yeah, it does not come out to be 0.54. You think how I guessed it. Oh, oops, sorry. I think the answer over here is marked already. Why is it marked? Oops. Sorry, guys. The answer is already marked. I'm so sorry. This was not supposed to happen. Anyways, now I'll solve the question for you. You know the answer. It's okay. The figure shows. Okay. The figure shows the position and the velocity of the two particles at 0 seconds. If the particle moves under mutual gravity, then the position of center of mass at 1 second is how many meters? Okay. Now, these are the two particles. I think their center of mass will be located somewhere. We can find that out. Just concentrate on this and on this. This is the mass. This is also the mass. So the center of mass will be located somewhere. Okay, maybe, I don't know, I'll just find it out. So initial position of the center of mass, I'll just write it over here. Initial position of the center of mass, I'll say XCOM naught will be m1 x1 plus m2 x2 8 upon m1 plus m2 1 plus 1 is equal to, now this is 2 plus 8, that is 10, 1 plus 1, that is 2, so this is 10 by 2, which is basically 5 meters. So the initial coordinate of the center of mass is 5 meters, so maybe the center of mass is somewhere over here. The center of mass initially is coming out to be at 5 meters. Everybody fine? But the problem is center of mass is moving. Why? Because the particles are moving. So the particles are moving. So first find the velocity of center of mass also. Velocity of center of mass is again m1 v1 plus m2 v2 upon m1 plus m2. m1 is 1, v1 is 5 plus m2 is 1, v2 is minus 3, minus because it's this side, m1 plus m2, so 1 plus 1. So 5 minus 3 is 2, 1 plus 1 is also 2, this is 1 meter per second. So every second it moves 1 meter. So in 1 second, therefore in 1 second, the center of mass moves by how much? 1 into 1, which is 1 meter towards the right side. Because this answer came out to be 1 meters per second, so it was going towards the right side, so it will move also towards the right side. So the center of mass moves by extra 1 meter. So the final location of the center of mass, guys, the final location, the final position, what will it be? 5 plus 1, which is 6 meters. Where is the answer? Where is the answer? Yes, C, option C. Very good. Is that clear? Oh, yes, C for captain, C for correct. Oh, amazing, guys. This is the correct answer. Moving on to the next one. Beautiful concepts in this question. You had to find not only the location, but you also had to find velocity, how much it moves, and then the final coordinate. So a lot of concepts involved. Okay. What is this? An object of mass 2 kg is moving with velocity of 3, collides with another object of mass 1 kg moving in the opposite direction with a speed of 4. After collision, both meet and they move with a common speed. What is the new speed equal to? Okay, this one is simple. Class 12 second revision, you mean from the board's perspective, Bharani Tharan, or JEE NEET perspective? If you're talking from JEE NEET perspective, well, you can watch my nurture classes, 0 to hero classes, which are quick revision classes. Okay, that is already there in the playlist. But if you are talking exclusively from board's perspective, like I have been doing, so maybe after Diwali. Board's perspective, yes, after Diwali, bacha. Not now. I think I did it till magnetism, matter, electrostatics, Gauss law, capacitors, current. All those chapters I did it from the board's perspective. I did the derivation. So from the board's perspective, just give me some time after Diwali. Definitely I will do it. Okay. Alright. So object of mass 2 kg is moving with some speed, head-on collision with another mass in the opposite direction. Let's draw. So this is this mass of 2 kg moving with what speed? 3 meters per second. Another body of how much mass? 1 kg. It is moving with how much speed? 4 meters per second. Great. After the collision, what happens is they become one single mass. So 2 plus 1 will become, let's say, 3 kg, and they move with one common speed v. Conserve momentum, nothing else is there. So conserve momentum. So conserve the momentum. Initial momentum is mass into velocity plus mass into velocity. This is initial. Final momentum is 3 into v. 2 3s are 6, 6 minus 4 is 3v. So this is minus 2 is equal to 3v. So v is equal to minus 2 by 3 meters per second. Magnitude of the velocity is just 2 by 3 meters per second. Just interested in the speed, not in the sign. So 2 by 3 in this particular direction is the final answer. Sir, I have a test with AIMS PYQs Physics Class 12. Will 0 to Hero series help with AIMS PYQ? AIMS is slightly difficult. 0 to Hero will give you till NEET level or JEE mains level. AIMS is slightly higher sometimes than mains or equivalent to mains you can say. So it will help you 60% but not 100%. Okay, 60% not 100%. Okay. Hi Munna, welcome. Hi Venkat Babu M, welcome. Hi Sanjit Krishna, yes bacha. All right. Thank you Rebel Mervin. Thank you so much. Welcome. Okay. Moving on to the next one. Now this is also very interesting. 3 balls masses given on a surface. The ball B has some speed. How many collisions will occur? This is also very common. HC Verma also has these kind of questions. So this is initially. So this is at rest. This is also at rest. Okay. Now the masses MA is equal to MC is equal to 4 times of the mass of B. So the mass of B, if I assume it as M, then MA and MC are 4 times the mass of B. So this is 4M. This is also 4M. After collision, what might happen is maybe B gets some velocity over here and C will get some velocity over here. This is V2. This is what I'm assuming. Okay. And meanwhile, obviously A will just stay there as it is. Nothing happens to it. Okay. This is the situation after the collision. Let's try to figure out what is happening. This is your first collision after the first collision. After first collision. So we can use conservation of momentum and also maybe coefficient of restitution. Is it elastic collision? Yes, all collisions are elastic. So I think we can do that also. So for these two bodies, B and C, using E is equal to 1. So separation velocity, they both are moving apart, is V1 plus V2. And approach velocity, this guy is at rest, this guy is moving. So approach velocity is just V is equal to 1. Okay. So from this V1 plus V2 is equal to V. So V2 is equal, okay, I'll just keep it as it is over here. Let's not worry about it. Now conserve momentum and see what do you get. Initial momentum is M into V. Other guy is at rest. See this guy is at rest. Now this guy has a momentum this way. So minus M V1. This guy C of mass 4M has a momentum that side. So 4M into V2. Now M cancels. Great. So V is equal to, I got from here, or rather let me put it the other way around. So here I'll get 4 times V2 minus V1 is equal to V. Now what I will do is just take this equation and this equation and basically add them. Just add these two equations, see what do you get. Take this equation and this equation and add these two. V1 and V1 will get cancelled. V1 gets cancelled. So you will get V2 if you would like. Okay. So what I will get is nothing but 4V2 plus V2 is equal to V plus V. So 5V2 is equal to 2V. So V2 is equal to 2V by 5. Okay. From this find V1. So use this equation and see what do you get. V1 plus V2 is 2V by 5 is equal to V. So V1 from here, V minus 2V by 5. 1 minus 2 by 5 is 3 by 5. So 3V by 5. Okay. You know now what I am doing? Once I got this velocity, it just confirmed that this mass actually moves here. Just imagine this value came out negative. This value came out negative. That means whatever I assumed is wrong. That means this mass B is not moving here. Where is it moving? It is moving there. So B collides with C and then it continues going in that direction. That would be the case if this came out negative. But luckily it came out positive. That means after the collision, B comes back actually this side. Obviously B will hit A, and once it hits A, that's it. It cannot again go and hit C. That will be stupidity. How can B already hit A and then it goes with a higher speed because it has to catch up to C? That is not going to happen. So after this, what is going to happen is that, this B, even if it goes behind, doesn't really matter. That's it. This will be the second collision. C meanwhile would have reached here with that speed. No matter what happens, B can't come back to C. Okay, it can't get back a speed higher than V2 no matter what happens, because it's anyways going to transfer some energy to A. So this will be the second collision. This will be the second collision. You have to stop solving the problem here. So the answer is 2 collisions. Let's find it out. Yes, the answer is 2. There you go. It can't be more than 2. No, Juhi, it is not 3, it is 2. Answer is 2. Yep. No, Munawai, it's not C, it's B. Yes, Kartikesh. Sir, when the remaining lessons are taken from chemistry, I can't comment, Jawahar. Physics for JEE 2023 Ultra Legend series or on Pathfinder. Pathfinder is over, Jawaharlal. Physics Pathfinder is completely over. All the chapters are there. Go ahead and check it out. Okay? All the chapters are there. So you can find anything. And what is this? Ultra Legend series is basically a complementary series, like problem solving, derivations, some tricks, some concepts here and there, some interesting things about the portion. That is what is Ultra Legend series for physics. Chamka sir, very good. Juhi. Chandrabose, yes, you are a little bit late, but it's okay. You can watch the remaining part of the session, and the whatever part you missed, watch it later on. Okay? Chalo. Moving on to the next one. Wow, what do we have? 10,000 small balls, each of mass 1 gram, strike 1 square centimeter per second per unit area, okay, with speed of 100 meters per second in normal direction and rebound with same speed. What is the pressure on the surface? What is the pressure on the surface? Okay. Now you take any particle of mass m, it hits the surface with speed, let's say u. After the collision, it rebounds with the same speed. Okay, it rebounds with the same speed, because of which it exerts some kind of force on the surface. Let's say I call it F1. So the force by any particle, any one particle, will be the change in the momentum upon the time taken to change that momentum. Change in momentum is mu minus mu. Reason for this minus is final is upwards, initial is downwards. So final and initial both are in the opposite direction. So that's why that minus. Change is final minus initial. Initial itself is negative of final. So be careful about that upon the time interval. Great. So this is just going to be 2 times of mu divided by delta t. This is for any one particle. So if I ask you what is the total force, you will be like n times the force by any one particle. N happens to be the number of the particles or the number of the balls which are falling onto it. So it will be n into F1. F1 is nothing but 2 mu divided by delta t. Great, this is the force, but the question is not on force, the question is on pressure. So the pressure will be the total force divided by that area. So it will be n into 2 mu by delta t into area. Now it's just a matter of substitution. Observe this carefully, guys. The number of balls falling per unit area, per unit second, everything is given. So the number of balls is 10 to the power 4. 2 is as it is. mass is 1 gram, so 10 to the power minus 3. U is 100, so 10 to the power 2. Okay, by time, so per second, so this is 1. Area is square centimeter, so 10 to the power minus 4. Come on, now do the math and see what you get. Juvi saying A, Javignesh saying D. Interesting. So what is the pressure coming out to be, guys? So 2 is there as it is. 10 to the power 4 is there. 10 to the power minus 3 is there. 10 to the power 2 is there. And this will also become 10 to the power 4. So do the math and see. 4, 4, 8. 10, 10 minus 3, 7. So 10 to the power 7 Newton per meter square or Pascal, whatever you want to call it. That's it. So that's the answer. Yes, option D, of course. I have no idea, Jawaharlal. I can talk about physics, bacha. Okay, so sorry. Alright, so D, yes, it is. Maybe a silly mistake. So maybe you forgot that 2. Generally, people forget that 2 and get answer C. You got it as A. Maybe you made a mistake in the powers of 10. Maybe you cancelled few wrong powers. Something would have happened over there. Or maybe you forgot that this was centimeter square. Something like that. I don't know. Anyways, so let's try the next question, guys. Can we find acceleration using V is equal to U plus AT and use F is MA? A. Which question, Kartikesh? You mean this one? The previous one? Well, how will you find A, acceleration? No. You can't find the acceleration using V is equal to U plus AT. No, that doesn't make sense. Here, the time is not the time for which it falls down. The time is the time for which it just reverses. Tuck. Initial momentum, final momentum, it takes some delta t time to reverse. Okay, Kartikesh, so I don't think that will be applicable over here. Maybe we can go to the next one. Particle of mass m moving with some speed collides elastically with another mass at rest. Mass m moves with v j cap after collision. What do you think is v? Wow, beautiful question. Let's try to first visualize what is happening. Mass m moving with u I cap collides with another mass at rest. Okay, so this mass moving with this speed collides with another mass which is 3m, and this is given to be at rest. After the collision, what happens is that this small m moves with v j cap, that means in the y direction. So this mass is going to move in the y direction with speed v. And that's it, elastic collision. So what will happen to 3m? Think logically. If this mass collides with this and this goes like that, this 3m will go somewhere here, right? Obviously, the momentum has to be conserved. Earlier, nothing was going in y-axis. This was just going in x. So if this goes here, something has to go down. So obviously, this 3m mass will have some component of velocity here. And since it has to conserve the momentum in the x direction, because this mass was going forward, something has to move forward. So there will be a component here also. This will be the resultant velocity, you might say. This is the resultant velocity. This is your x component. This is your y component. This is your root of v1 square plus v2 square, the resultant velocity. Is that making sense till here, guys? Oh, thank you for reminding me. Now think what equations you will write. The next class, Muskani, Shriram, my class will be on, I think, Friday or Saturday. Yeah. And this chapter has been already completed in the Nurture series. Just watch the playlist. How many days will it take to finish the chapter, Leah? Chapter is already done. This is problem solving series. If you want to watch the chapter, it's there in the playlist again. Nurture series, Leah. Number 2, if you are trying to do it on your own, I feel that this chapter of momentum and collisions takes easily 5 days to 6 days on a daily basis, assuming that you are involved in other things and you have other subjects also, easily. Thank you, Jui. Thank you, Harishrudan. All right, let's do this. Thank you, Ms. Kani. Sivagami, please speak in English. Sorry, Siva. I'm so sorry. I was talking in African languages. I'll just come back to English. Okay, I'm so sorry. I'm so glad you reminded me, Siva, that I should talk in English. So let me switch back from Afrikaans to English language now. Okay, so over here, this mass is moving, collides, and these are all the velocities that I assumed. Oh, this is a previous year question. What is the value of V? Okay, I think we'll conserve momentum. Hi Arya, welcome back. Okay, Siva, thank God. Siva, I'm talking right now in Afrikaans. I was just kidding. I did not switch to English. I'm still talking in African language. I'm so sorry. Okay? So I think I was just cracking a joke there. I just told you that I'll switch to English, but I just fooled you a little bit. I'm still talking in Afrikaans. So maybe you will not be able to understand what I'm trying to say right now. So conserving the momentum, guys. Conserving the momentum in X direction and Y direction. Conserve the momentum. Conserve the momentum. So initial momentum, well, that is just mu. That is just mu. The other guy is at rest, so 0 is equal to final momentum in X. This guy is not moving in X, it's moving in Y, so nothing over there. Plus, this guy in the X direction is 3m into V1. Okay. Yes. So moving on. To the next one. Looks like you guys have had your own fun moment over there. So this was your X direction, guys. So what do you get from this equation? Is m get cancelled. So I will get V1 is equal to U by 3. Okay, I'll just keep it as it is. V1 I got it. Okay. Now similarly conserve the momentum in the Y direction and see what do you get. Here there is nothing in Y. Everything is in X. So 0 plus 0, nothing over there. And over here, this mass is moving up. So plus mv. This mass is moving down, so negative. So minus 3m into v2. Again, you will notice m and m will get cancelled. So bring this guy over here. So 3v2 is equal to v. Therefore, v2 is equal to v by 3. Okay, still nothing. v1 is u by 3, v2 is v by 3. What do you do now? You want to find v, guys, in terms of u. Harisudan Jui saying B option. I don't know. Let's try to figure out. Harisudan saying U by 3. Interesting. Let's try to find out now what to do next. I feel we should conserve maybe energy because it is elastic collision. You might be like, sir, why not E is equal to 1? See, I can use E is equal to 1, but it will be crazy. It's a 2D problem. The coefficient of restitution in 2D, it involves components and all. I don't want to unnecessarily get over there. Instead I'll use energy. I think it will be simple only. If it is not, then I'll come back to restitution. So energy conservation. So elastic collision initial is equal to final. Initial energy is just half mu square. Do you see that? There's nothing moving, only one mass is moving, so half mu square is equal to this mass's energy is half mv square plus this mass's energy, be careful, it is half 3m this guy's square, so it will be v1 square plus v2 square, the resultant velocity square. The root vanishes. The root has just vanished. Okay, maybe few things here and there will get cancelled, like half, m. Okay, I am just left with u square is equal to v square over here plus 3 times of v1 square. Where is v1? Oh, it is here, u by 3. v1 is u by 3. So u by 3 square plus 3 times of v2. v2 is v by 3. So v by 3 square. Great. Now observe what I am trying to do. U, v. Bring identical terms together. So let's see what we get. So u square is as it is minus, bring this guy over there, minus 3 times u square by 9, because 3 square is 9, is equal to, is equal to v square as it is plus this guy. So 3 into v square by 9. Now 3 by 9 is 1/3. 1 minus 1/3 is 2/3. So 2/3 u square is equal to, this 3 by 9 is also 1/3. 1 plus 1/3 is 4/3. So 4/3 of v square. 3 goes, 2 and 4 also goes. So u square is equal to 2 times of v square. What do I have to find? V. So v square will be u square by 2. So v will be u by root 2. I think I got it in whatever form I want. So it's option D, guys. It's a beautiful question. Yes, it is u by root 2. Yes, it is u by root 2. Yes, Kartikesh, option D. What a brilliant question which was asked in the previous years. So that's why you should solve these Tattva questions which has this good collection of problems. My aim is AR1. Non-area NEET aspirants Kita K2 Irukan calculus. We have to solve 200 MCQs for physics and chemistry. I'm not sure which language was that, but I'm guessing it was Malayalam or Tamil. Yes. Whatever, I don't know. Maybe you can translate it for me, Bacha. Okay, very good. So, guys, this year, we had 2,688 students qualifying for advanced. Out of this, 2,500 students cleared advanced. Like more than 90% ratio, guys. Okay. And 480 students scored above 99 percentile. Vedantu students, long-term batches. We don't count students who just come for one day or just enroll. Many institutes do that. They just give one test paper, that's it, their rank is printed. No, we don't do that. Okay. 2,000 plus students above 90 percentile. And these are our toppers. All India rank 104, 105, 149, 172, 168, 150. And perfect scorers also. 25 students in physics, 4 in chemistry, 4 in maths. Physics was easy this time. So all of this are available in case you want to prepare yourself for the final exam. There are a lot of JEE courses available for you. Link is there in the description box. You will not only get the courses but also the material, assignments, also doubt solving and the revision series with mock tests. I'm in fact conducting the revision for the 12th standard batches. Some of you might be, if you're from 12th, you already know that I'm taking your classes out there. Chalo. So guys, this is what I want you to realize, that you have to solve a lot of questions and not just from one single book, which might be, making you feel that, these are the kind of questions. So you should have a book, even if it is one book, which will give a complete picture of the exam. And I feel Tattva has those quality of questions. It not only has PYQs, but also simple, hard, variety of questions. It's a mixed question. We have made a lot of efforts to make this Tattva book. So make sure you are solving this in case you're a part of Vedantu. If you're not, then try to get the book from somewhere and maybe you can solve it, or maybe just enroll into the courses itself. All right. So thank you very much, guys, for joining in. I hope you enjoyed it. I hope you have smashed the like button. Keep coming, and yeah, make sure you attend all the live classes. If you can't, then watch the recorded classes. Okay. So thank you guys very much. Have a great time. This was Captain Shreyas signing off. Hasta la vista.